In this video, we're going to be solving equations of quadratic type, specifically trigonometric equations. Now, many trigonometric equations are of quadratic type, meaning they're of the type ax squared plus bx plus c equals 0. So to solve equations of this type, you need to factor the quadratic, or when factoring isn't possible, you need to use the quadratic formula. So some examples are quadratic in sine of x and quadratic in secant of x. Notice here that our a value would be our sine of x, or 2 times the sine of x, and then we'd have just 1x, and then minus 1 is our c value. And so that's where those would be. So let's start off with an example where we're going to find all of the solutions of 2 times the sine squared of x minus the sine of x minus 1 equals 0 in the interval 0 to 2 pi, which means that we won't have to be adding 2 plus 2n pi to each answer. We're going to begin by letting u equal the sine of x, which is going to give us a 2u squared minus u minus 1 equals 0. From here, we're going to see if we can factor this. So there's lots of different ways to factor when our leading coefficient is not a 1. I prefer this box method of the Punnett square, but I like to call it a disco box. So I'm going to take the first thing and put it in the first box, so 2u squared, and take the last thing and put it in the last box, and then we're going to multiply those things together. So we're going to take 2 times negative 1. Now the u's that go with the 2, those will go in these other boxes right here, where our factors will go. So we're looking for two numbers that will multiply to negative 2, but will add to our negative 1 right there. And so in this situation, the only numbers that will multiply to 1 and 2 are 2 and 1. Then, based off of our negative symbol here, that tells us that our symbols are going to be different. And based off of the minus sign here, that tells us that the larger number is going to be the negative. So that would be a negative 2 and a positive 1, which when we add that gives us the negative 1 that we were looking for right here. And so we're going to take and put these numbers into our leftover green boxes. And it doesn't matter which one you put them into, so we'll do that. So now we're looking for, what do these two numbers have in common? And they both have a 2 and a u in common. Those both have a 1 in common. This column, each of those things has a u in common. And here, there's not really a number that goes into both, so we're going to go with the number 1. And because we have the negative in that front box, that tells us that that's going to be a negative 1. So in this upper one, we'll have a u and our negative 1. Then we're going to take our top piece here. So we're going to take our u minus 1, and we're going to take our 2u plus 1, and we're going to set those equal to 0. And now we can use the zero product property here. So we're going to have u minus 1 equals 0, and 2u plus 1 equals 0. So solving then for u is going to give us a u equals 1, and on this side we'll get that u equals a negative 1/2. Now we'll replace our u, because remember that our u was really the sine of x. So we'll plug that in now, and we'll see that we have the sine of x equals 1, and the sine of x equals a negative 1/2. So if we look at our unit circle, we want to know where the sine of x equals 1. Remember that our sine function is talking about the y values, our y values. So where is the y value? A 1. And in this case, we see a 1 here is our y. And that's the only place we see a -1. And so we're able to say here that x equals pi over 2. And we also want to know where the sine of x equals a -1/2. So again, where are our y values? A -1/2. So if we look around our unit circle, we see that that happens right here and right here. And so that tells us that x is going to equal 7 pi over 6, and x equals 11 pi over 6. And again, because we were given an interval between 0 and 2 pi, that means that it's only going to happen those 3 times altogether. So we can say that our final answer is x equals pi over 2, and x equals 7 pi over 6, and x equals 11 pi over 6. And those are our final solutions for this problem.